Okay, I think we can start now. Um, Today, as I told you on Thursday, on Tuesday, sorry, it was on Tuesday, our last lesson. Um, we are gonna show a practical example about an end-to-end data capture pipeline process. And as I told you on the previous lesson, the objects for today, we are going to see the practice architecture that was the one that I explained last day. And after the demo, we go over all the components we talked last day. So now we can see how they working and all the logs they produce. So you can understand how they works. And at the end of this lesson, I will explain you what we expect you to do for your practical report. That would be something similar but easier. So, but I will tell you later that you are gonna be able to choose different options if you think you are capable of add more complex to your report. The architecture we are gonna see today is this one. So it's practical, the same I showed you last day, but today we are doing real-time capture process with a PLC. Here I'm using a Schneider PLC, and there in the slide, I'm telling you the IP from the PLC and the capture, the protocol, the communication protocol we are going to use. We're going to use Modbus TCP so you can see different options of different protocol communications and how they can be configured inside a IoT gateway as Vnode. So the protocols, it's going to be Modbus TCP. This 102 is the standard port for this protocol. And it's just so you can check how an industrial protocol works, and so you can see how we can configure. And then also we are explaining more high level from, because as I told you, it's like typical for the IT layer or the meanwhile to transfer data from the OT to the IT. So you'll see how this protocol, as it's more structured, it's more defined, it's going to be easier to get the data in or configure the data capture in a gateway IoT. This is the Vnode IP that's going to be on my local host on my computer. And then on Docker, I will have the Postgres, Grafana, MQTT broker, Mosquito could be, Telegraph, and InfluxDB. And we'll explain how we are configuring all of this in a Docker stack. And we're going to see how we can enable each component, and we'll see how start working all of this. So let's start with the demo. The first thing, okay, I'm gonna try check. Okay, here. Okay, so the first thing we should do when we connect with the PLC is to check if we have connection, or at least the part where the gateway IoT is installed has connection to the PLC. So the data transfer, the communication transfer could be possible. The first thing, or one of the common thing, is to check it with an IP request. Okay, so here we're validating we have connection, and also we should check also if the ports for the Modbus TCP and from the OPC UA protocol are open. So that means that from here, where I have the gateway IoT, I'm going to be able to ask the data from the Modbus TCP. So the PLC has these ports open and it's listening on it. There are plenty tools to check that. You can use a telnet to be the easiest or the simple way to validate it. If you can do a telnet with that port, that IP and port, and the telnet connects. Or this is another tool from the PowerShell on Windows. Here with this command, we can check the port, and after a moment it's gonna okay. So here now we validate that this port from the Modbus TCP is open on the PLC, and then we're gonna validate it from the OPC US side again. Okay, so it's working. So now we can go to the vNode, to the gateway IoT part. I'm gonna here we have. Okay, so this would be the vNode interface. It's a web application, and here in this menu you have all the possibilities to check the modules, the links. This is to configure this feature that I told you on the previous lesson, that where you can have a vNode, a local vNode, and different local vNodes and a central one. So here you can configure the communication between the central and the local one, and also what part of memory, what different tags you want to make visible to the next component. Also, you can, from here, if you have the logs from the different modules enabled, you can check online what are you what if there is a problem of if you need to you have parsed some with with JavaScript protocol, you are making some calculation. So here you with logs or with prints, you can validate if they are working properly. Here in the module section, this is all the modules that have installed. From here, you can check the license. For industrial purpose, you should have a production license, but here, for you always can use a demo license when you use when you configure this module. If you don't have a license for you have paid for a license, then you always have a license, a demo license. And with this demo, you can start the data capture process using that protocol for 2 hours. After 2 hours, this module stop, so the data capture process stop, but you need here to restart again. But you don't have any limitation above that, or you can use all the features from the vNode. So that's why we usually use this gateway IoT for demonstrations, because you can test it as in all the features, in all full of license, but and this is not a problem, because for the demo you're not gonna need more than 2 hours of data capturing, and if so, when it stops, you just need to restart again. So here then in this data, you can see historical, if you have, as we can see for tag, for each variable are defined in tags, and in each tag, you can define if you want to add a historical record. And if you have added, then you can, here, you are able to see how this variable is, it's the evolution of this variable over time. And the real time, that be the what are we now reading from these variables. This here is the variables that I have pre-configured from the PLC, and as you can see, as the modules are stopped, they are not working. And here in the config section is where this section is where you can configure all the let's see, the important thing, all the modules, and also all the tags. Here in the is where you configure if you need to if you want to, for example, you want to divide the tags over with different folders, if you want to separate different components or different departments or different processes, whatever, you can make you can do the model you want. So okay, let's start with the data capturing modules. From here we have the Modbus TCP. So here in the module section, you will click on new module and you will see, well, let's gonna do an example. So you can check here, this the screen, it appears after creating the new module. And then here in the type, you can see all different capturing protocols or methods that the vNode has available, from reading from an SQL, from Modbus, from OPC, from text, different factory manufactured protocols, proprietary protocols like Siemens, the S7 ISO TCP protocol we talked on the previous lesson. Or if you want to read data from a database, you have different modules. Also, you have the scripting module in case that your protocol is not defined here, but you are able to program that protocol to get the data. You can use these scripting modules, and you can program your protocol so you can communicate with your device. Okay, here for the Modbus, we will only create the Modbus client type, and here are parameters that are used to live on default. That it's like if we want to restart the module if something happens, if an error occurs, and how many retries you have, and after what delay. And also, but I think it's about connection. If, for example, because you just for Modbus TCP, you can have different PLCs where you have capturing data. So here you need to create just one module, and then inside of the module here, you are creating the different connection. For example, if we are connecting, here is for a Modbus simulation on my PC, and another connection to this Schneider PLC. Here is where you put the connection. And here is where you configure if you want to enable this connection, so you can capturing data from this, or in case that, for example, now I don't need to get data from this connection, but I'm not interested in delete it. Just in case, I just can disable the connection, but no deleting. And with that, the Modbus will not connect through this IP port to get the data. Also here, from each connection, you can configure what is the timeout, because in the Modbus, you has to, as a client, you has to ask to the server with memory, with data in memory you want to capture, to get the data for. So here you configure the timeout. If you send the request but you don't receive the response from the Modbus server. If you don't receive that response, how many attempts you will make? And just in case you complete this attempt, if you want to try to reconnect to this device, or in case that, for example, if a device has the Modbus TCP block or has stopped for any reason, here you can say no. So the vNode would not start to reconnect. It doesn't try reconnecting over time if the device is not working. When you made this connection, the Schneider Modbus connection, then you need to add the device you want to read on that connection. And here in the device, you need to select what is the slave ID. Because why? We need to configure this because Modbus TCP or Modbus RTU, it works like in a bus. It's a communication bus. So in the same IP or in the same bus, if it's over serial communication, you can have plenty of devices. You can have until two, at least more than 100 devices. But each device, just to avoid collision of packets and to avoid losing that traceability of who is sending the data, each device needs to have an ID, a unique ID that identifies that device in this network. So for us, the device here, the device has the ID 1. Also here you can configure the block size. That's how many memory I'm gonna try to read in just one request. And the swap, in case, because it's typical depending on the device, that the architecture, if it's a big endian or little endian architecture, and it depending on that architecture, maybe the more significant byte is swap. So with here you need to, if you are working with a different architecture, you need to say if you need to swap the bytes, the word, depending on its 32 device architected device, if it's a 64. So you will configure that here. So after all, when you read the data, you can read the value correctly. So with that, we made the configuration of the connection of the device we call Schneider, and then we need to configure the tags for that device. Here, if I don't get wrong, if I'm not wrong, is this. Okay, in the PLC, just for the demo, we are simulating two different pumps. So we are going to be able to see the evolution of the speed of if the pump is on alarm or not, and the status, if it's running or not. This data is simulated, and also we put just a counter so you can see the different variable. So yes, this variable is capturing over Modbus TCP. So the Modbus TCP, as probably you have seen on the lessons, it's about a word-oriented protocol. So all the registers are on a word. All the information are stored in word registers. So here, to collect the data first, you need to determine what kind of variable you're going to read, if you're going to read a number or a string variable or a Boolean, because the system treats it different. And also the type, if it's a float, if it's a integer 16, whatever. And here you can define the dead one. That's the as I told you on Tuesday, that in several gateway IoTs you can define what is this threshold. So instead of collecting data or inserting data to a database each time a variable change, and it has a lot of precision. So here with this deadband, you can adjust what kind of precision I want. If I want with 1 decimal, with 2 decimal, or instead if I want just the unit, if I want the unit. So changes smaller than the unit won't be considered. The client access, if for me this data is going to be only to read, or it would going to have a read and write access, for example, we will see in the command variable of the pumps that we configure as a read and write variables, because that's the signal where we're going to be able to start or stop the pump. And also here, the persistence, if just in case the gateway IoT lose connection or stop capturing data, if we are seeing the last variable, and or we haven't seen as I put it none. Here you could see that the last value is not it is on red, because the last value is not being considered as it was a correct value. If we record it on memory, probably we'll have like the connection is still on, but the timestamp will indicate that what was the last time we collect that data, but we won't get the connection on red. Here in this part is, here in detail here that's detail, just to give some description if you want to see that here on the real time. Here in the simulation part is where we configure if we want to, just in case, as I told you, yeah, for example, we don't have the PLC of a Modbus device to collect the data, we can simulate here. And then just to continue our data pipeline, so we can validate that we are registering the data in a database, and also we are seeing the historical registers on a graph. Here we can simulate the data, and we start simulating depending on the type of number you have decided. It start to giving different values, random values. Here in the scaling is where you make a pre-processing, but about the units, because not in all protocols, but in Modbus, it's really typical that to keep this protocol simple, as it works in a word register method. Imagine I want to store a temperature with 1 decimal of precision. Here in this protocol, it's really typical to put the value, for example, in one register, in a word register, but multiply by 10. So if I want to have the, for example, 20.0 degrees or 20.1 degrees, I will write here 201. Then in this part, we need to make that, so what's the raw value, what is the minimum and maximum, and the engineering units, the one converted, what is it was from here, it was from imagine I can have from 0 to 1,000 the value. Here in the engineering, if I'm using 1 decimal of precision, I need to divide by 10. So here I would say 0 from 100. And with that, I will get the data in the real data. That's a typical case of use in Modbus. So the processing of this calculation of the data to have the real value, it's typical to be done in the application layer, not in the protocol. Here we configure the source of where the data capturing process, where the data is coming from. And here we'll enable that. If we enable that, it has priority over the simulation. So if you want to simulate the data, for example, and you want to enable that, you need to disable the source field if you are using a device to get the data. Here you need to indicate what is the module, in our case a Modbus client module, what is the Modbus name, the module name, that's the one that we define here when we create the module. And after that, then we need to point to the device we are going to capture the data. And for that, we need to indicate the connection, and then the device. So what we define here, this is the connection, the IP with the port, and the device. So that's what we configure here. In the Modbus address is where you indicate what is the register you are gonna read or write depending on the mode. And here you can, in the help section, you can see that depending on the number you put here at the beginning of the address, you are locating here in this gateway IoT what is the memory area where you are using from the Modbus. Here with the 4 is we are trying to read a holding register area. That's the part of the register which you can read and write. If we are reading with a 3, we will read an input register, and in this area we just only are available to read the data. So in that area, if we try to make a write command, it will fail. But here in this holding register area, we can read and write. And also if our variable is a Boolean, here it helps you how you can configure how you access to that bit, or a string, the same here. If it would be a Boolean with a point, then would you select the bit from the word register. Then here in the data type, you will indicate what type of information you're reading, just so the gateway IoT knows if this variable it's just in a reading one register and treating as a signet or signet, or it needs to read 2 consecutive registers or more, and how it need to treat the data, if it's a float, if it's an integer. So here's the fine. And also the scan rate. As I told you, in the Modbus protocol is the client which periodically makes the request to the server. So here we will configure here in milliseconds. So here in this example, the gateway IoT each second will make the request to the PLC to get the data, this data. So that, I think we made a review of all the parameters you need to configure from the Modbus TCP capture architecture. Here in the history is where I told you that you can, if you enable and you configure how you are interested to save the data, if it's periodically, or if it's with the event of the change in the variable using the deadline, if you want to just register with what precision you want to make the register. So that's what I told you, that if you configure, then you can here you can see the evolution of this variable here in this part, in the historical part. And also alarms. Yes, here you can configure if, for example, this variable goes over a value or whatever, you can have some alarms in this gateway IoT. Okay, so here with the Modbus, we have the Modbus protocol explained. Let's gonna explain the OPC UA client. The same way you will add a new module of the type of this type, the OPC UA client, and then you need to add the client connection. In this case, the PLC, the Schneider PLC. This is the protocol for the endpoint, because it's typical. Here we are going over TCP, so for indicating that you need to configure this star in the endpoint, and then it goes the IP and the port. Okay, so here it's the OPC UA protocol. It's about subscribing to variables. So you here the same as the previous, you can enable or not, and here you configure what's the maximum items you can configure per subscription. It's here a channel will make a subscription, and in its subscription, what is the publishing interval, and what all, if how many notification, because here, for example, it's 1 second, you will ask from the PLC how many data, how many variables have changed since the last second, and then you will have a row of all the possible value of the values that from that variable during that second. But here, as the PLC, we configure the PLC, the variables are changing each second. So with that, we will have each time we get a notification of the change of that variable, we will have just a change, just one change. Okay, so now we want to talk about the tag definition using that protocol. And I'm going to show you how easy is to add the tags here using that protocol, because as I told you, this is a high level protocol. So it's well structured. It's structured in a tree form. So when you read the endpoint, you know how the server is structured and where are the folders inside the server, just with the browser. So as you can see, once we have defined the connection, here we have this OPC. Okay, the certificate section is because here, as we are making that demo, we are not protect this protocol. We haven't protected even with the user and password, but here you can have different methods to about what we told you, that's typical about authentication, authorization, and encryption of the data. So here you configure what kind of security policy your OPC UA server is using and what is the security mode. So if you need to configure a user and password depending on the security mode you have selected, or also if it's encrypted, the connection is encrypted, here you can import the certificates, the server certificate, so you can understand the communication, the data. You can decipher and decrypted that data. Here in the OPC browser, as we were talking, as you can see here in the client. Okay, so yes, it's getting the error that the OPC module is stopped. So, oh, it's client. Sorry. So it's not gonna be able to make that browser that browse of the of the client. So here we will have all the different connection we have a configure here in the OPC module section about connection, and then selecting the one we want, that the Schneider PLC. You will see okay, it's gonna make some uh, just in case I change something, and then okay. Not connecting. Let's check what's going on. Okay. So here apparently we don't have any problem. It's checking that we have these different endpoints from the PLC side. Okay, it's gonna discard also these changes just in case. Okay, let's validate. Let's start the Modbus TCP. Okay, so it's working. The Modbus TCP is working. It's run with the probably maybe as I configure here. If I have this OPC US server configure, do I have any problem with that? Okay, so here it just I'm gonna restart the PLC just in case it has. Because it seems like the OPC US server is not working. Okay, so if you have seen, the system has detected that the connection is being closed. So that's why I told you that the OPC UI client module was working, but it seems like it was a problem with the PLC. Okay, here we have. No.
There is a problem.
No, but it's problem with the capture, but it's normal and it's okay because it's really typical when even in easier communication it's really typical. So it's okay if you if you can see a problem on direct. So so here in the browser, okay, let's gonna do it again. No, okay, that's what I want to show you. Like here, when we select the client, we'll see the tree in the server side, in the OPC US server, what the PLC has on it, and you can go over all the folder. And typically in the object folder, here you have the server information and also the data. And as as you can see, in the Modbus TCP configuration, we need to go over, we need to configure and create a tab individually and configure all the parameters. But here with the OPC UA, the information that the server is giving us about the memory area and what the type of data we are getting, and also the access level, we just can select all the variables we want and drag to our tag module here, as I drag in the previous when I was configuring this demo. So you can see is the same variable. And then here you don't need to complete this information about the variable, the data, because it automatically gets that information from the server. And also, as I told you, if it's what is the access type of the variable, if it's read only, or as we told you before, it is a write and write variable. And this about the sorts, all the communication when we select the client and the memory where the client and the memory that we need to subscribe to get that information, it's all configured by itself. So here, when you drag and drop on the folder you want, you just need to save that data, so you can have all the variables. And after that, we have configuring the data capture, all the data capture process. We will be here in this part here in the gateway IoT. Now we have all the data independently from the capture the communication protocol, or if they are from different devices. And now following with that, what we're gonna do next. So we have configured here this first typical industrial part, where from the gateway IoT here is where we're gonna make the insertion to the PostgreSQL database. As I told you, we can have, in the meanwhile, that's why I'm gonna tell you, that's why I had the OPC US server protocol configured on the vNode, because it's possible to have here an application client that acts as an OPC UA client, and this device serves all the variables or the variables we want using an OPC as server. So here we can, as you can see, we are dividing and selecting and isolating the capture process from the application layer process. So you have different methods. One would be using this module, the OPC US server, and just configuring which port you want to listen for the inputs connection with different clients. And here you configure what you want to act as a server. If you want to allow the anonymous users without any kind of security, or if you want to protect the data with authentication and also with encryption of the data. Or also what we can do is, as we saw in the slide, is directly from the gateway IoT, we are gonna transfer that data to the database, to the relational database. And for that we have this Postgre. Well, it's an SQL, it's SQL module. It's not a Postgres, but here in the, well, maybe yes, it's a, you add a new channel. No, it's an SQL. It's an SQL. So it's a relational database module, and then here you can select what kind of relational database you are using. If you want Postgres, you would do the Microsoft SQL Server, MySQL, MariaDB SQL. Here you configure the connection parameters to connecting that database, the username from accessing that database, well, the typical parameters to access a table or a database. And then here in the transaction, you will select what kind of transaction you want and what when you want to do that transaction. If it's as here in a fixed time, periodically it's 1 second, or if you wanna make it with a cron tab, or even if you wanna configure if one of the parameters of a variable change. Then we configure different parameters. I divided the tags I want to register here from the memory of the gateway IoT, the speed here in tag 1, the alarm in tag 2, and the status in tag 3 to work with these tags inside the query I'm creating to make the insert. And here in the query, you can work with JavaScript to program the query you want to make. And also, if you want to make some kind of pre-processing before storage the data, here you can do as it's a programmably, as it's a typical script. But before activating this, and before, well, okay, let's just finish with that with the query. Here I'm configuring what the table name I'm gonna access, and the name of the sensor is for the sensor 1. Here I will store the pump 1 variables. Okay, and then here I'm configure what type of variable, what is the variable, the name of the variable I'm gonna collect. That here it's in Spanish, but it's the speed, the alarm, or the status. And then here in the output with this command, you will indicate what is the output of this module. And here for us is this function that it's an insert function. And here is where I'm putting the query to inserting the values of the tags of the 3 speed, alarm, and the status value that I associated with the tag 1, 2, and 3, and then here I'm selecting that I want the value from that variable. Okay, so before activating this module and see what's going on, we're gonna go through the Docker section part as I told you here. Now all the rest of the components from the practice, I'll have it in a Docker. So I'm gonna explain and to make that Docker stack where I define all the isolated components I want to add in the stack. We use a Docker compose yarn file that when you deploy the Docker, you execute the deployment of this yarn file, and then the system automatically recognizes what are the isolated containers that the Docker stack has, and it deployed individually. It's going to display from just for point to a point. Here for the Postgres, I'm calling the Docker. I think I saying that this is the Postgres Docker. This is the image I'm using. That is for just in case I don't have the image on local. It tries to get that Postgres with that version from the repository, from the Docker repository. Just automatically download the Docker image. This is the Docker name I'm gonna configure for this container, so I can then when I want to work with that or validate how this container is working, this is the name I'm gonna use to localize the container. Here I can configure if for any reason, for any problem, this Docker shut down automatically, then here with this order, it's gonna start again until I manually stop the container. Here is the environment to create the user and the password from the database, and also the name of the database, the ports. In this section, you can make visible ports from the Docker to the host. So from the host in here, for example, in this example, directing from the host to this port is gonna translate to that port on the Docker side to connect with the database. And also here we have the volumes in case we want to map some memory or some information from the Docker part to the host part. So we can make some configuration or some commands that the Docker is gonna receive on a startup. Here the data from the database is gonna be stored in this folder on root, the Postgres data folder. And here we have the root or the directory inside the Docker that it's going to be visible through this folder here in our local host. And then here I'm telling that from the root directory where I have this Docker stack, I'm going to put this SQL command, and it's going to be treated as an entry init db command. So what does mean that the first time this Docker deploy is going to execute these SQL commands. What I'm doing this, I'm going to try to demonstrate. Okay, where I have the other screen, just a moment. Here is my root directory from this Docker stack. here, as you can see, I have the Docker Compose YAM that I'm showing you, and here is where I have this in the root. Here is where they have this init SQL command. That's the one that I'm telling the system that needs to be executed the first time I deploy this Docker, and you can see this SQL command is a basic command to just create this table sensors in case it doesn't exist with as this is a relational database, it's structured with columns and row. So this is the schema, the fixed schema of the database. I'm using an ID that's a primary key, and this is the indexing in the relational database is priority, is mandatory, even mandatory to have a good relation of the data. With that, I'm telling that I need to auto increment each time I insert a new row. And then here is when I'm gonna insert the name, the type of the value. When the name would be sensor, the type that if it's speed, alarm, or status, and then the value of the variable and the timestamp without time zone. So the first time I deploy the Docker, it's gonna create that table. So when I start the Docker, this is the Docker stack, and as I told you on the previous slide, I can I can run the whole stack, or I can run the process, the containers independently. And here, if I start running the container now, as the table exists, if my capture data capture sorry process can start inserting data without any problem. If I have that, and when I deploy the Docker, I didn't have the database, the table created, it start failing. So here with this tool, the pgadmin, we can see the database, and also we're going to see the table. So here, as you can see, we have this database, the sensors database that we have created here in this section of the Docker. And inside of that, on schema, you can look for the table sensors with the columns. Sorry. The columns we have defined, that ID, the name, the type, value, and timestamp. Okay, yes. These are data from a test I made before starting this demo, just to validate that all the system was working. We're gonna delete. Okay, so now we have cleaned the table, but the structure is already done on the first deployment of the Docker. Sorry. And now we can see that, okay, we're collecting the data on real time. Yes, it's second, more or less. And here in diagnostics, if we run the PostgreSQL module, we need to see that immediately it's going to start getting the data. Let's gonna filter for the last value, 3 values. That be the okay. Oh, I'm gonna put it in that. So now with the select, you're gonna see that. Ouch. It's enough. No. I'm gonna just a minute. I'm gonna remove this in the select the column. So just okay. Okay, so you can see that we are getting the data from the first pump, the sensor one, the pump one, the speed here, the velocidad in Spanish, alarm and status. And if I made the request, it's a second more or less when I'm inserting when I configure the PostgreSQL module in this gateway IoT to make the insert, you will see that the data correspond to the value of the variables. If we, for example, we can write this variable, we saw that we have configured to have a read and write access. So I'm gonna make the test to force as when it receives the command, the pump it's gonna stop. The status of the pump is gonna be on or false, indicating that it's not working. And as you can see, the speed is not working. So here you can see in the console that you have the historical data of this part, and it's making insertion. It's 1 second. I'm gonna filter with more data. So you can see that the block of insertions are the 3 variables, and it inserts each more or less each second. Okay, let's gonna start again the pump. And it has to start working again. Okay. So we have this part with the PostgreSQL storage process validated. And now we are gonna continue. Okay, with this part, we're gonna go through the visualization tool, the visual tool at the end of the presentation. And so let's gonna go over this part. Although this is typical from doing this from different devices, that one device, for example, the PLC, maybe it's communicating over Modbus, another device is communicating over OPC UA, and another over MQTT, and we can go with MQTT with this using the gateway, and then the gateway publishing to the broker. but also the device could publish on the broker directly. But here, just for the demo, we use just one device. So we put all the demo communication protocol in just one device. Okay, so let's continue with the MQTT broker. We'll see the next part of the container, that here I'm saying that I'm using the Mosquito is the broker. That's the image I'm using just when, in case that I made the deployment, I don't have the image on local, it's gonna download from the repository. That's the name I'm using. The same, the restart, if you want to restart. These are the map port here. In this case, if connecting to this port, we're gonna connect in the Docker MQTT broker with this, the same port. And here is the volume of the data we are mapping to our host later. So here in the root directory Mosquito config data and log, we are mapping this folder or this file from the Docker from the Mosquito on the Docker side. And here with the MQTT client, we can see that. Okay, with MQTT here. Okay, if I try to connect, I'm gonna get the error. I am not being able to connect as the Docker disconnect, as the Docker is not running. In here, if I run the MQTT broker, as I told on the broker, then is connected immediately. As it was trying to reconnect, it reconnected immediately. And here I can see the broker information, just like how many clients we have connected. And in this case is just one. It's me as the explorer. And what is the version of the Mosquito MQ2 and different here it where the server will store the information. If we have this retain flag activated, or if we have that retain flag, what is the storage message, the store message that the broker is carrying for that retain flag, and all the information that we can check how the broker is going on. In the capturing part, capturing and data transferring part, because we are now more in the data transferring process. Here we have a module, MQTT module, MQTT client module, because we are a client and we are going to connect to the broker. In this case, to make to publish over different topics to send the information. And here we create the connection. We're indicating where are the IP, in this case the local host, and the port where we are gonna to connect. Here if the possibles of about quality of service and all the to make them more reliable, as we saw in the previous lesson, all the things you can configure. And then here I made different publishing methods. With here you can publish periodically each 1 second or whatever, with different snapshot, what is the last information we have. Or here with this configuration, we are saying that on events, when each time the tag filter, this filter, in this case the alarm, the alarm variable is changing, we are gonna make a new MQTT message. And here, just to make more efficiently the communication, the transfer communication. I'm saying that I'm publishing with a maximum of time of 1 second, and I can in that second I can put 10 message for publishing, for a publish transaction. So here with the as we configure on the PLC the alarm, or well, maybe no, not the alarm. The alarm just is the worst case to explain, because the alarm is not configured as the pump enters on full each second. But for example, the counter of the status neither. The velocity, they are changing. We have on the PLC simulating to change over a second. We will see that mostly we will each second we will receive a new topic, a new publish of in this topic now, and this on the counter topic in this topic, or in the speed topic, this topic we have configured here with the value of the data. In the message format here, you can include what kind of message you can create for publishing on this topic. And for us here was the simple one. We get the data. We get the data each time the event data value. So the last value of the variable when it changed, and then we put it on the outside. So we are just publishing the value of the variable inside this topic. And so what we are gonna see on the Modbus when we on the Modbus, no, sorry, on the MQTT broker, when we start this module, we're just gonna see that each second we will receive topic from a speed counter and speed counter variables, and then when the status on the alarm variable change from the on the PLC, we're gonna receive a new publish from that topics and different topics, but not at frequency. So here in diagnostics, we're gonna run the MQTT client, and here in the MQTT here, as you can see, we started receiving the data from sensors, sensor 2, and then velocity counter, as you can see here in the when it goes on black, when it remarks, or here in the historical event of the variable counter, for example, it's receiving the data, it's 1 second, more the same as velocity. We're getting the data, it's 1-2 seconds, depending on the frequency of the simulated variable, but the alarm of the status, we just receiving we are receiving just when it's changed the value. Okay, so now we go over the next. So here we have the broker, the MQTT broker, that it's getting the information. Okay, I'm gonna just show you something. I'm gonna show you. Check. Imagine. Okay, let's gonna try first. I disconnect from the server, the client disconnect, and when you start connecting again, it's quite fast. So we are not seeing quite well, but I'm gonna try to force that. If I stop the client, the MQTT client, it will stop publishing data. Okay, so when I'm connecting here, I receive the last value of the variables, but if I disconnect, if a client disconnect or a new client connect, it's not gonna receive the information of the it's not gonna receive the information of the topic. If we configure, as we put here, for example, it's gonna put it on the speed. If we configure here a retain flag, as we talked in the previous lesson, okay, it's gonna I think it's gonna start automatically. So if we check now the MQTT, it's starting. And if now I stop the client and I disconnect and I connect again, as you can see, although my client, there is no new publish of the data, the new client, when it connect for the first time, it receives the last value from the speed, the last value from the speed variable, as we configure here the retain flag, as the one that we saw in the previous lesson, that if we want to validate or to check that each new client that connects to the MQTT receive the last actual value of a variable or the last status of a variable, for example, it's useful, this flags. I told you that's, I just want to show you how you can use it, and that's and why you can use that, because for example, if you are working with robots, maybe when you change the workspace of where a robot is working, probably here to simulate that I stop the module, so the MQTT client stop publishing. But it could be, for example, because I can have done without stopping the module if I put on the alarm on the status. Probably the robot, when it changed the environment or it changed the workspace, the active workspace, it published this message just one time with the retain flag. So when new client, but it won't publish again, although it not change again from another workspace. So with that, if a new client connects at any point of the working of at any point, it's gonna receive that message, that the last message with the actual active workspace of the robot. So here, as you can see here in this gateway, in the IT gateway, how it's easy to configure, and you have seen the result of configuring that. Okay, so let's continue. Now we have here the information on the broker, and then we're gonna go to this data collector, the Telegraph one. Again, we're gonna go first to the Docker part of that. Okay, let's gonna go. So here it's simple. It's simple to configure. But as you can see in each Docker, its container, it's at least for a basic behavior, it's really easy to configure. You need to say what image you want to use, what is the name you want to, how you want to identify the container, and then here I'm telling that it depends on MQTT and InfluxDB. You can also configure dependencies, and then here the volume, because Telegraph, when it starts, it works as an agent, as a service. So when it starts, it reads a config file. So it knows what parameters need to load and how it should work. So here, from here, I'm telling you that in this directory, this file here, in the this file in the in the root from the Docker stack in Telegraph folder. Here I'm putting the config, and I want to write on here this config file on this part of the Docker. So when we start the Docker, it reads the config. And as you can see here in the Telegraph, and then here the Telegraph config. And what we config on this service. So first, here we config if the login part, if we want to debug or not, if we want to log or not. Then we configure what is the capturing, the how, what's the interval to get the data from the MQTT broker, and also what is the interval to flash, to batch this, to transfer this packet of data to the database, or to the output, to the output that in this case is a in time series database. But then here you configure the input plugins, and for us, for the demo, we put an input that it's an MQTT consumer, and this is the parameters to configure that plugin. Like you need to indicate what is the server connection, which topic you are subscribing to. In our cases, is the one we publish on Sensores, Sensor2, and then we want from the topic Sensores, we want to get all the data. So here, if we have sensor 1, for example, or sensor 3, we will also receive that. With this plus, we are saying that we want to subscribe to all the topics in meanwhile. And then here we are saying that the data we are getting from this topic is a float data, and how we want to parse the data. That here is the part where we can filter, or we can tag, include some tags and some metadata to each variable. Here for us, for the example here, we're saying that each message we are receiving, or each topic we are receiving, we are including this tag. So in this part of the topic, we are indicating that it's the sensor ID, and the last part of the topic we're indicating that it's the type of the variable for us. So when we go the data, when we have the data inserted on the database, we have these fields configured, so we can filter by sensor ID, saying selecting if we want the information from sensor 1, sensor 2, sensor 3, depending on what we have received. And then when in sensor 2, for example, what is the variable we want? If we want the speed, the alarm, the status, whatever. And then after configuring all the input, in this case we just have one input plugin, but you keep with this form, you can configure multiple input plugins, and this is from the output. And here in the output, we're saying that we're using Influx DB. These are the connection parameters and the token. And we're saying that the information we're getting from the input, we are storing in the bucket called Sensores from that database, and also localized by this organization that I put it here on default. But the bucket would be sensors. So now let's gonna. Okay, I'm gonna start Telegraph. Here, you can see here that, well, when it started, it load that config file. So it is now receiving the MQTT information. Here you can see you can go over the different containers to check to see the logs from from each Docker container. And here, as you can see, as we haven't run the Docker from the InfluxDB, you can see here in the logs that he's receiving data from the MQTT, and when at the period indicated when it tried to transfer to store that data, the connection with the InfluxDB fails. And as you can see, that's the batching part that we mentioned on the previous lessons. This is the metrics we can store on by default, but then in the Docker, in the yarn file, in the Telegraph config file, we can configure how many metrics we are able to store in case that a connection with the database fails. And here, as you can see, each time it tries to store the data, as it cannot, the buffer is increasing with the old information. When it reached the limit we have configured, the 10,000, it will start discarding the oldest value. So, but until we reach the limit, we are getting the information storage on buffer, and when the communication just connect fix, it's gonna transfer all the data in a batch. So let's gonna start the database. So you can see now that, okay, it was quite fast. I don't know if we're gonna be able to see that logs, but okay, so it was not able to write on a media, but now here, as it was able to make the connection, all the buffer, as you can see, it was able to write all the batch of metrics, and now it's starting the time we configure on the config file on Telegraph, it was like 10 seconds. It's storing the metrics it's receiving each 5 seconds. So as we talk here, it's receiving information each 5 seconds, but it's storing each 10 seconds. So here, this is important to if okay, although you're gonna have all the data because you're flushing all the information. If you want, for example, on the exploitation of the data, if you wanna see a real-time graph or a real-time icon that acts as the last value, you need to be aware of what you configure here, because here in my visualization tool, with this configuration, it has gonna have a delay of refresh of 10 seconds. That's when we receive new data. Although in this 10 seconds, we're gonna have a refresh gap, but when it refreshes, we're gonna have the information of all the 10 seconds. We're not losing information, but our visualization tool is gonna have this 10-second gap. So if, for example, if we wanna just okay, so here you've seen that each time he tried to make a new insert, it's 27, 37, 47. It's 10 seconds. So if we can change that, it's so simple as make kind of And although also you don't, it's nonsense to configure the flush interval to be faster than the interval we're getting the information from the capture process. So it would be nonsense to write here less than 5 seconds. But if we want the system, for example, to respond each 1 second, we need to put the interval to 1 second, and then depending on how we want to respond, our visualization tool, how to respond, if we want each 5 seconds to refresh the data or each second, we need to configure this. So here in this, now I change here to flash the data each 5 seconds. So as simple as what I could have done here in this part. I restart the module. And start working. Let's wait for a second to. Okay, as you can see, we are trying to route to the database in these 5 seconds instead of the 10 seconds. So as you can see, we can make this process. We can make this component working as simple as I told, like with a Docker, like just modify the config parameters and then restart the Docker file and it will start working as you want. Okay, let's gonna talk about here. Yes, okay. About now let's gonna talk about the InfluxDB database. Here is the token to connect to the database. Here in the Docker, we see here what is what is the web page to manage the information from here. From here, we can see what is the visual or of the same as pgadmin, the motor to graphically see the database. So here the InfluxDB has its own on this endpoint. And now this is the web. And now here would be the first thing we need to do. Here we need to go to the API tokens, and then we need to generate white API tokens. So Grafana and Telegraph could use that topic to validate, to authenticate from the database and be able to connect to the database. Here, as I created one, I created various of token. When I generate a new one, I can, if I want to, a custom, so you can select what parts of what bucket you have only access to, or you can give it all access to the token. Here I clone the one so I can use the same token, because the first thing you have to do is to create a token, a new token. And with this token, that because you need to save this token, because once you close that window, you're not going to be able to see that token again. So it's important. Up here you have all the access rights you have for that token. But that's why I told you that it's important to store that token before closing the window, because if not, you're not going to be able to see that token. That's why I clone so many times the same Grafana and Telegraph token, because I wanted to get that token. And that token is the one you have to write here in the Telegraph config. So it can connect to the database, because if not, the connection is not going to be able to connect. It's not going to be able to connect. Telegraph is not going to be able to connect to the InfluxDB, and it's not going to be able to store the data. So once you have that, Telegraph now it's getting the data from the MQTT layer, and it's storing in Influx database. And here in the buckets section, you can see that here are all the. It's seeing so small here. So here you have the list of all the buckets that your database has, and this is, as you've seen, is the bucket we are inserting from Telegraph. So when the first time it's inserted, it's gonna create this bucket, and as you can see here, okay, so here we have this tag we have added to the variable on Telegraph, the sensor ID, the sensor 2, and then the value. So small. The sensors field and the value field, and then so here in this graphical web tool, you're able to see the in a raw view the data we are getting, and also if more representative in a graphical way, and you can just make the request of the data its minutes, or you can validate that you have received data. You've been receiving data, and your Telegraph is working, and it's putting the data on the bucket you have selected. So let's gonna go over this slide, and now here we have this part from the gateway IoT to the database, and we have seen that we have the historical records on the database, and also we have this part with the Telegraph with this data agent getting the information and storing on InfluxDB, and now we have also the InfluxDB the data on the InfluxDB. So we are gonna finish this demo with the visualization tool with the Grafana component. Okay, on the Docker Compose side, okay, that's the information we need to give, like the port from the web from the web management page, and that here we are mapping the same port. What is the container name, the same, and the environment, what is the user and password we're doing to the tool. And here in volumes, we can configure what information we want to give it from the beginning, the first time it deploys, and provisioning on dashboard. That means that you can have a dashboard created, or the provisioning is the information of the data sources, of the connection of the data sources, in this case Postgres and InfluxDB. You can have the in files this configuration of the database, and also a dashboard to be graphed, to graph, or to be visualized. And you can make that the Grafana tool use that information from the beginning. If you put that information here in the Grafana provisioning and dashboards. In provisioning here, the data sources. The data sources are configured on a YARN file. Okay, I have it here open. And from the beginning, when I first deployed the tool, I only configure the default connection like as the Postgre SQL, and I connect what is the URL, the endpoint of the connection, what was the name of the database, and the user and password to access that database. But as you can see, I didn't define the InfluxDB connection. And for the dashboards, here I was saying that it used the information from these dashboards, but at the beginning, if I'm going through dashboard, the folder was empty. So at the beginning, the first time I deployed the system, it's not gonna be able to. It was not able to use any dashboard. So I had it blank, and the Postgres connection was the only data source I had configured. Why I made that? Because for me it was more simple to configure. Okay, the Postgres connection that was only protected with user and password, it was simple, so that's why I put it configure. But the InfluxDB connection, as if it needs the topic for the token for the connection, I prefer to create on the directly on the tool to insert that token. And with the dashboard, it was like the same, because when as the graphical visualization I want to do is quite simple, for me it was easier to go over the tool and create the graph and or the series, and not just use a file to load that information. So I don't know if I started. No. Okay, so let's gonna start the Grafana container, and then on this page we can see in this page we can see the web tool of this component. Okay, now it's warning that I'm using the default password, but it's skipping anyway. So that's here. This is the web page for this tool, and here in this we have. Well, let's gonna start with the data sources. And now they are the ones that are configured. Here, this one is the default because it's the one that I configured at the beginning. Because as you can see, like, is the URL, the database name, and the username and password. Once I configure it was here, you cannot see it. So the configuration of the Postgres is immediately with that information of the URL, the URL and the endpoint of the server. But on the InfluxDB, I prefer to create a new data source of type InfluxDB, and then here I'm choose what is the query, because depending on the version of the InfluxDB, we are using InfluxDB 2 something, but we are using the Flux language. In another version, you can use an SQL-like language. So Influx, here are the connection, the authentication, but what it was important is here, because in the InfluxDB, the details for the connection, here I have to configure the organization, the bucket I want to connect by default, and the token. So that's why I didn't configure this connection at the beginning with the YARN file. Okay, now, so once you have configured all your data sources, you can go over the dashboard field, the dashboard menu, and then here you can create new dashboards as the one that I'm show you on the demo. It would be here. You can have a dashboard from the sensor one. Here I'm putting the speed and the alarm, and the same from the sensor from the pump to the speed and the alarm. And here you can configure which are the what's the last value you want to show. For us would be, for example, we want for 1 minute. And also you can configure the refresh interval. As the minimum here is the 5 seconds. That's one of the reasons why on the Docker compo, no, on the Telegraph config, I'm not gonna go lower than 5 seconds because it's nonsense when Grafana by default it's gonna it's not gonna refresh faster. So here, as you can see, it's 5 seconds. Mostly it's 5 seconds. You're gonna have the data, and also if the alarm changes the value. We're gonna go over the graphs just so you can see how they are represented. So you can create a new this type of graph is a time series, and here you just give the name of the time series, the name of the graph you want to represent. Also, you configure, well, if you want, in my cases, I didn't represent the points of the value we had, but here you can represent what kind of graph you want to print. And also, what is the display name? The layer, the information of the variable you are representing, so you can display here the select what name to display. And the important thing, it would be like here, as you select what is the data source you are using. For sensor one, remember that we store that information on Postgres. So from PAM1, we are using Postgres, and the select is now we are filtering the name sensor one and the type velocity speed, okay, order by timestamp, by descending timestamp, so I can have this form. From the alarm, it would be a stat, so I can here I select that I want to represent the last value of the variable, and with this value mapping is where we select the icon I want to represent and the color of the icon depending of the value we receive from the query. And then the query, just I'm with the limit one, I'm getting the last value because it's ordered by timestamp, by descending timestamp, and using the alarm variable, I'm getting that information with that select. And for the PAM2, I just want to show you, because the time series graph is the same, but here, as my data source is InfluxDB, you can see like the query is different. The query is quite different because here with the Flux language, I'm selecting what bucket I want to get the data for, and the range if I want to the last hour of data, and then I'm filtering with these tags, with the tags from the variable, that's the the measurement, the sensor ID tag, and the type tag. In this case, the velocity, the speed of the value, and also I'm filtering because I want the value, the field value to get the information, to get the value of that variable. And with this is where I get the time series historical records. And from the alarm, it would be this in the same bucket, and I'm getting information from the last minute, and I'm filtering by the type alarm, and I'm getting the last value. So with that, I'm getting the last value of the request, of the Flux request, to get the information of the alarm, of the PAM2. So I think that with that we have finished all the demo of all the components that we want to show you how we can integrate an end-to-end data capture pipeline process with a basic exploitation layer that it will be the visual graph or tables. So, but you can see how all this process is working. What would be the last point, or what we add to our system? So it could be a complete data process, a data capturing process. We include a connection to the MES system, to the ERP system. So with that connection, we can import the fabrication order from the factory or from the process we're working on. So in this capturing process, we can relate that fabrication order with the information we have been capturing of PAM1 and PAM2, and that would be a complete industrial capturing process. So what we want for you to do on your practical exercise, it would be a report, just a write report that if you have a sensor, or it's gonna be kind of free, because if you have a sensor or a device that works on a specific protocol and is not fixed to use, you're not able, it's not mandatory for you to use OPC or Modbus. So if you have a device that works with a specific protocol and you want to integrate it on the vNode gateway, you can do it. But if not, you can use a Modbus simulation. For example, if you don't have any device. We will give you a PDF with all the information where you can get these programs. But I'm gonna show you, so you are being a bit familiar with that. This, for example, it's a Modbus TCP protocol. So here I'm choosing what part of memory I want to select, and I can write information if I want to write on FLOAT32 or on decimal, but it works on each register. It's a word type. So here you can configure different values, or even here in the program, I don't remember where it was, on what part of them. Okay, here, simulation. Here you can have, for example, you can activate a simulation to increment, for example, what increment on words. So if you activated that, you will have each I don't know, that you can configure that time. Yes, it's 5 seconds here in this simulation. It's 5 seconds. You will have an incrementation of 10 or whatever you want to configure. But I'm meaning that if you don't have a physical device to connect, you can use a Modbus simulator, so you can simulate as this program is a Modbus server. So with this program, you are simulating the PLC part, and then you will have to connect with the vNode system to create these modules connection, the connection, the tag definition, and with that you complete the capture process. If, for example, you get stuck in the Modbus simulator or whatever you don't are able to make, just don't stop doing the practice. You made the report and you configure the tags to be simulated here from the vNode. So at least you can continue with the end of the practice, and then from the practice you can store the data in a Postgres or in MySQL, wherever. If you have another tool, you can connect the IoT, the vNode IoT with that database to store data, or the one who wants to be more brave and go over here, that wants to have a Mosquitto and publish with MQTT and collect the data and store it in another type or no relational database, you can also go over that. But we want to make the practice or using like this, and getting the information and store it, the information. Like you don't need to make anything on the exploitation layer, but again, if you want to do it, you are more than welcome. And just on the report you make, following all the or writing or commenting on all the steps you have get, and how you configure with the screenshots and with the configuration you've done to validate that your report is correct. You can complete wherever the basic is the data capture process and storage on a database. You can include, or it would be better for you to include or the device or the Modbus simulator or whatever. But just to make like you have a device here, a capture process, and then storage on a database. But you can go with the storage directly or with the MQTT. That's whatever you want. So here we finish the part. Any doubt with this demo or with the activity you need to do? Everything clear? Okay. Okay, so I haven't seen in the chat any doubts or any problems, so we are stopping here that lesson. Thank you for attending the lesson. Goodbye.